Hello everyone, welcome to our channel Wisdom ML. So in this video, we will be talking about how we can detect monkeypox using skin lesion images. And this project will be very interesting for you because it's a very new data set. And in this type of project, you can also use for your portfolio project. Okay, so in this project, we'll be talking about the monkeypox disease, how severe it is, and what are the treatments available. Then we'll talk about the data set we'll be employing in this project, and then we will talk about the overall project structure and which models we'll be using, what will be the overall approach. And later on, we'll be sharing some of the results which we have obtained after applying different computer vision models, pre-trained models. And later on, we'll also talk about sample predictions, which is provided by our best model. And we'll also see how to improve our. So in this video, we'll talk about overall project structure, design, and about the monkeypox disease. And in the second video, second part, we'll be talking about the overall model building part, in which I will give you the code walkthrough, and we'll also share the code with you so that you can train your own model on monkeypox dataset. So first of all, we have to know that what is monkeypox. So monkeypox is basically a skin-related disease, and it is caused by a zoonotic virus. It is a type of virus which is spread from animals to animals or animals to humans. Okay, and monkeypox basically primarily affects rodents, rats, mice, or monkeys. But it can also occur in humans due to close contact with infected animals or already infected person or with any material which is already contaminated with the virus. Okay. Then the symptoms of monkeypox are somewhat similar to smallpox disease. Smallpox is, you all know that it is also a skin related disease in which we get some rashes over the skin, and it's also mostly occur in children or in young age persons. So monkeypox is basically an old disease. It's not a new. Okay, and the first human case of monkeypox was recorded in 1970 in the Democratic Republic of Congo. So most and now also majority of cases are actually occurring in Democratic Republic of Congo region. Then from the 1970, it later on spread to other West African or Central African countries. But recently, as we all know, it is spreading in a very alarming rate, and it spread to other regions also, like UK, US, Australia, Portugal, Spain, Canada, and it's now also spreading in some parts of Asia also. So what are the treatments available? So according to WHO, vaccines used for smallpox can also be used for monkeypox. Okay, and now newer vaccines are also being developed, and out of which one has been officially approved for prevention of monkeypox. So soon maybe you will be getting the vaccine in the market, but we don't know how much time it will take. Another good news is that an antiviral agent is also developed for the treatment of smallpox, and that is also licensed for treatment of monkeypox. And these 2 points are directly referenced from WHO. Okay, so the treatment we actually read in WHO and bring these points. Apart from that, we know that for monkeypox, we don't have any treatment available. Okay, so now if we talk about how severe the monkeypox disease is, so it is typically presents with fever, rash, and swollen lymph nodes, and it can also lead to other medical complications. Okay, and the main point is that monkeypox is a self-limiting disease like chickenpox or smallpox. Uh, it is a type of viral because we know that mostly virus don't have any particular medicines. There are some antiviral medicines, but usually doctors don't give medicines for viral infections. And so this is also a self-limiting disease, and it usually lasts to about 2 to 4 weeks. Uh, so the very concerning part is that the complications of monkeypox include secondary infections also, which includes bronchopneumonia, sepsis, encephalitis, and infection of cornea, even with ensuing loss of vision. So you can understand how uh, serious this disease may be. Okay. Now, if we talk about the fatality ratio, so historically, from 1970 till now, if we talk, so fatality ratio of monkeypox has ranged from 0 to 11%, and it is seen that it has been higher among young children. Okay. But recently, as we all know, it is spreading at an alarming rate with a fatality ratio of 3 to 6%. So, and it is increasing day by day. Even in US, UK, some of the South Asian countries also, we are seeing cases. And recently, we also heard that one person in Kerala, India, died due to monkeypox. So now cases of fatality is also coming up. So, and so one of the important thing that we have to understand that once we get any disease in the initial stage, so if we detect it in the initial stage, it is very easier for the doctors or for the overall treatment process to be successful. Okay, because in that way we can do some precautions, we take some prevention so that it may not spread. We also sometimes in the initial stages we give some medicine for experimental or some proper medicine. It will also affect well. In the initial stage, body develops immunity and fight against that. So it is very important to detect any disease in the initial stage. So that's why in this project, our aim is to develop a diagnostic system, image-based diagnostic system, in which based on the skin lesion images, some of the sample of skin lesion of monkeypox affected patients or other infection affected patients, we will train our model on that, and will after training the model will predict whether the person is actually suffering from monkeypox or from any other disease. So now it's very important what data set you are using. So as we know, there is no proper data set available right now. So there is one data set in Kaggle we have found, that is monkeypox skin lesion dataset, and I will also provide the link in the video description. You can go through this dataset. So in this dataset, basically they have snapped images from the internet websites, some healthcare websites, and taken the sample images of monkeypox and chickenpox and measles sample images, skin lesion images, because there is no official or research dataset available for these types of diseases, skin related these types of diseases. So in this data set, along with monkeypox images, you may also find other disease images like chickenpox and measles. But it's a binary classification data set in which one class belongs to monkeypox, whereas another class labeled as others, and it may consist of other types of diseases like smallpox, chickenpox, and measles. Now, about this data set, that this data set has basically three folders, and you can use any one of it. Like first one is the original images, in which we have total 228 images, of which 102 belongs to monkeypox, and remaining 126 belongs to other states. Okay. Second is the augmented images, in which we have augmented images in both the classes. And images are augmented using different augmentation techniques like rotation, translation, reflection, shear, hue, saturation, contrast, and brightness jitter, even noise scaling. Okay. And the third folder is fold one, which is one of the three cross validation dataset. And the distribution of images in this is somewhat like this. In training, we have monkeypox of 980 and others 1162. For validation, we have monkeypox 168 and others 252. In test set, we have monkeypox 20 and others 25. And now the thing is how come these large number of images come in the fold one? So fold one consists of both original and augmented images of both the classes, and that's why the number of images are increased in the fold one class. And in this project, we will be using fold one dataset. So in the first step, we'll be resizing the image into 224 cross 224 size. Then we'll be normalizing our images by dividing it by 255. This will bring down the dimension of our image into the scale of 0 to 1. And this step is really very important because it will help the model to converge easily and faster. So that's why we'll be doing image normalization. After that, we'll be converting our images into NumPy images. This step is very important basically because sometimes what happens when we load the images, it may take a lot of time, okay, in Google Colab also. So what we'll be doing in this, that we'll convert the images into NumPy arrays and save it into NumPy. And later on, you don't have to load the images physically from the directory. You just have to load the NumPy arrays which are the converted version of the images, because all the steps and processes will be applying on those converted NumPy array. Okay. So after converting into NumPy arrays and again loading from NumPy arrays, we'll divide our images or split our data set into train and test. In this, we'll divide our data set into train and test set into 80:20 ratio. So 80% of the images will be used for training our model and 20% will use for on the fly testing. Okay, so we run our model in the training process. We run our model for around 50 epochs, and in every epochs we'll be training our model and parallelly we'll be testing our model on this validation data set, that is test set. So after training our model, the main part is that we have to load the model having the best weights, the weights which have higher accuracy. So we'll load our model having best weights, and then we will evaluate our model on validation set. So this validation set is already provided in our in this data set as a val folder. And as we have not used this validation set in the entire process, so this set will be completely unseen to our model. So we'll evaluate the performance of different pre-trained network like BGG16, ResNet 50, and MobileNet V2 on this validation set, which is unseen to the model, and we'll see how much performance it will take. And then we'll do the prediction. So whichever model is the best model, will do the predictions, sample predictions, and we'll see how it is performing on some sample unseen images. And if it is doing some wrong predictions, then what will be the reason? We'll discuss that. So, and the output of the model will be something in the form of probability, because we'll be using softmax activation function here. And you know that softmax is generally used for multi-classes scenarios where the probability will be the sum of all the classes. Okay, so you will be getting the probability in terms of 0 to 1. So the class having higher probability means that image particularly belongs to that class. So here, as you can see, that the monkeypox has 98.2%, while others is 1.8%. So this particular image, after going through all of the process, we'll getting the prediction for this image and we'll getting 98.2% monkeypox detection. Now comes to the model result summary. So we have already performed the evaluation of three models, pre-trained networks, that is MobileNet V2, VGG16, and ResNet 50. So these models are basically pre-trained in the sense they are trained on ImageNet dataset, that is the largest dataset with hundreds of categories, classes in that. And these pre-trained networks perform relatively well in this data set. So that's why we'll use these data set, these pre-trained network for the recurrent learning, because whatever they have learned in the data set, so they have some basic capability for classification. So we'll be using their power for classification and doing certain fine tuning in terms of hyperparameter tuning in the layers, so that it will be customized based on our data set. So you can see that test accuracy is somewhat, so here we have evaluated based on these 5 parameters. Test accuracy is accuracy which we use during the model training. Okay, so this part is seen to the model, so we cannot say it is unseen. So this is usually high for mostly when we train any computer vision model, but you cannot claim any accuracy percent or the actual performance of the model based on this accuracy, because this test set basically we are using during the model training process. So actual performance measure only we can validate our model only on the unseen data. So you can see that here our MobileNet V2 performs well, 97.89%, whereas ResNet 50 also performed well with 95.09%. But VGG16 actually fails to detect any pattern, and it has only 56.0%, which is almost a random. Now, if we talk about validation accuracy, so this accuracy is on basically test set which is completely unseen to the model. That is the validation set. And here we can see that mobile V2 also performed well with 78.80% accuracy, whereas VGG16 has 60% accuracy, while ResNet 50 has only 40%. So that's the major difference. And this is the actually validation that actually determines the success of any computer vision model, because on unseen data, how your model is performing, it is actually the main part, because it tells the efficiency or actual detection rate of your model. Now, if we talk about precision, so precision is somewhat higher for MobileNet V2, only 79%. Recall is also higher, 81%. Recall means how much efficient or how much accurate your model is in predicting the actual monkeypox cases. So it is 81%, which is not bad. And we must remember that it is completely unseen data. Now, the third is F1 score, which is the balance of precision and recall, harmonic mean of precision and recall. And in here also 79% it is giving. So it is not that it is the final. So we can always improve our model by including more number of images, by doing some more augmentations, by doing some further fine tuning, by tuning the batch size, by tuning the layers, by changing some optimizers. Okay, so it is quite important to understand the first view of your model with the default parameters without hypertuning, how much it is learning on a first pass. Then we can always improve based on the initial. Now, two things we found in this whole project. First is MobileNet V2 definitely outperform others on unseen data. while MobileNet V2 also performed better on this small data set. So we should remember then when we have a smaller data set, in that case, you should, if you are planning to use any pre-trained model, so definitely try to use MobileNet V2 because this is really very compact model and always gives good performance on a small data sets. And on deployment part also, you can deploy it because it is usually takes lesser space on hard disk, so easier and very smooth in terms of integrating with any application. Now this is the sample prediction part. So after selecting MobileNet V2 as our main model, we have performed some sample prediction on validation set that is the unseen data, and we found that in most of the cases, that is out of 12 cases, right? We have three wrong predictions. You can see this, and this, whereas nine predictions are right. So if we see quickly what are the right or wrong predictions. So one thing I must tell you that within the bracket is the actual within the bracket is the actual uh, class or class of the image, whereas this part is the just before bracket, this part is the actual prediction of the model. So this is the true class, this is the prediction. So now if we analyze this part, so now if we analyze the first incorrect prediction, so you can see that actual is others while our model is predicted as monkeypox. So as we know that monkeypox rashes or the initial rashes are somewhat similar to smallpox or measles or chickenpox. So it may happen that in the training data we should also we have certain images in which we have an initial stage of monkeypox having lesser rashes or these types of infections, which is looking somewhat similar to monkeypox, but it is not monkeypox. It is any other disease, maybe chickenpox or measles. Now, if we go to this one, so this one is basically monkeypox, but it has detected others. So if we see, it is quite resembling with other disease because it is on the first view. If we see, we can see that it is somewhat similar to very less severe disease or maybe initial stage of chicken pox or measles, but actually it is a monkeypox. It is so because due to the very close similarity between chicken pox, smallpox, or monkeypox, these types of errors may happen. Okay. And this is the third one. So if we see, these are the two predictions in which, in this case, it is predicted correctly, but in this case, it has not. The reason is that the image or the infection part, the affected part, is somewhat tilted towards the middle, whereas this is tilted towards the upper part. So maybe due to some positional effect, it predicted monkeypox, but it is actually in other segment. So from these sample prediction, we may understand that we should understand that the model is somewhat dealing with a very complex problem in which one class is very closely associated or have very close similarity with the other class. So that's why the validation accuracy on unseen data is also low, whereas in some of the cases it predicted wrong because of the sentiment. So it is our first attempt to use computer vision model in predicting or detecting monkeypox cases. I hope the data set will increase, the size of the data set will increase, and we can build more robust models if we get more images. I hope you like our video, and the next part will be doing the code walkthrough of the whole model building process, how we have used MobileNet V2 and how we'll build this model and all the results section. So Till then, have a good day and stay tuned to our channel. And if you have not subscribed our channel, then please do subscribe so that you will get the notification of our latest videos. Thanks, guys. Have a good day.